Hey class, today what we're going to talk about is linear regression and how to create a line of best fit for a set of data, even though the data is not perfectly linear. Um, so let's first start with a context for our problem. Um, so we've got the Riverside Adventure Club is planning a spring skydiving lesson and a first jump. So people want to go skydiving, they're going to go do this jump, and what they're going to do is they're going to videotape it. Uh, and then they're going to take a poll of their members as to whether they would like to purchase it and for what price they would like to purchase it at. So, like, if it costs $25, there's going to be 93 buyers of that from the club. If the cost of the video is $30, that's going to make it 89 people buy it, and so on and so forth. Like if the cost of it is $75, only 38 people. So if you notice, as the cost goes up, less and less people are going to buy it. So what we want to do is that Adventure Club is we want to find that sweet spot where we're going to make the most amount of money by charging the right amount to where we'll maximize our profit. So what we first want to do is we're going to create a linear model for this data. So what you need is a graphing calculator in order to do this. So grab your graphing calculator. You're going to start by entering in the data. So you start with your stat right there in the middle. Press stat. You got to turn it on first. Press stat. You go to here. You're going to press edit. So you go to edit, hit enter. All right. Now there's stuff into L1 and L2. What you want to do is clear those out. L1 is going to represent your X's. L2 is going to represent your Y's. So you press up, highlight L2, press clear, and then hit enter. That'll clear that out. Go over here to L1, press up, clear, and then hit enter. Alright, so now we've got our data cleared out. Now what we want to do is enter in all of our data points. So if you notice my X's, I go up, so I got 25, 30. So as soon as you type in a number, you just hit enter. So 25, enter, 30, enter, 35, enter, 40, enter, 50, enter, 60, enter, and 75, enter. So now you have all your data in L1, and so now what we're going to do is put in L2. So L2 is my Y's, that's my number of buyers. So I type in 93, 89, 77, 71, 64, 55, and 38. Okay, so they should match up down at the bottom and have the same amount of data points. If this ends up being mismatched, it will tell you later on whenever you try and plot the points to look at it on a line. So what we want to do next is look at the scatter plot. So in order to look at the scatter plot, you're going to turn your scatter plot on. So you press second right there, and you're going to press Y equals, and you're just going to bring up your stat plot menu. Now if you notice, it says stat plot up there in yellow, so every time you see anything in yellow, you press second, and that'll go up there. And we want to turn that on. So you hit enter. Right now mine's turned off, so you hit enter, and then you want to hit enter there to turn it on. Make sure that it's highlighted as the scatter plot, and then you want to make sure that your X is L1 and your Y is L2. The mark doesn't really matter. Okay, so now that you've got that graph, you put all the information in. So now what we're going to do is plot the points. So you're going to go to zoom, and you're going to go down to number 9, which is zoom stat. So we entered in stuff into stat, so that means we want to zoom stat. So number 9, hit enter, and if you notice, my scatter plot looks pretty much linear. So that means that we can create a linear model for this. So now in order to make the linear model, we take our scatter plot, we're going to press stat, we're going to go over to calc, up there at the top it says calc, and you're going to go down to number 4 where it says linreg, which stands for linear regression. So linear regression is just a line of best fit, which is going to be the linear model for this data. So you hit enter, and then you're going to come up with this. If you have one of the TI-84s, you're going to scroll down to where it says calculate and just press calculate. But if you have this, you're just going to hit enter, and then it comes up with Y equals AX plus B. Now it's very similar to our Y equals MX plus B. A and M are the same thing. So A is our slope and B is our y-intercept. So now we have our linear model. So whenever it says create a linear model, so we now have y equals I'm going to round this a little bit. I got negative 1.07 times x plus, I'm just going to round this to 118. Okay, so that's my linear model. So what this means is, actually let's round this to 1, and this is going to make calculating stuff a lot easier. Alright, so what this means is I've got negative 1 times x plus 118. My y-intercept is 118, which means that if my cost was 0, I would have 118 people buying that video. And then every time I add a person, I'm going to lose 1 viewer. But that means every time I add $1, I'm going to gain $1 profit. So it's kind of a give and take in this situation. So now that we have our linear model, I'm going to go ahead and rewrite it up here. So I've got my y equals negative 1x plus 118. So now what I want to do, and this is kind of the whole point of a linear regression or anything in the linear model, is we can now predict. So we want to figure out if it costs $45, how many people are going to buy it? If it costs $70, how many people are going to buy it? And so on and so forth. So what this is, if you remember the cost, we let our x represent the cost, y was the number of buyers. So what we're going to do is plug in for our model up here. So I got y equals, I've got negative 1 times 45 plus 118. So that means y, if I have negative 1 times 45, that's negative 45 plus 118. That gives me, I should know this, but I'm going to cheat today, minus 45. So that's going to give me 73. So I know that if it costs $45, I'm going to get 73 buyers. Same thing if I put in 70. So y equals negative 1 times 70 plus 118. So my y equals, that one's 48. So I'm going to have 48 buyers at $70. Y for 90, I'll just go ahead and do that math. So that's going to be 28 if y is 90. If my x is 110, sorry, that's if my x is 90, my y is 28. And then if my y is, or my x is 10, my y would be 108. And then this one's going to be a little tricky. So I got 125, so that means I've got y equals negative 1 times 125 plus 118. So that means my y is going to be negative 7. Now, in this case, negative 7 doesn't really make sense in our problem because you're not going to have negative 7 people buy our product. So it wouldn't really make sense to go beyond 118 in our problem. So then that kind of builds into our domain and range. This would fall under our domain, can't really go above 118. Otherwise, our problem doesn't really make any sense. Now what we're going to do is kind of reverse that. And now we have 50 buyers, 75 buyers, and 100 buyers. And we want to figure out how much it's going to cost if that's going to be how many people we want to sell it to. So it works through the reverse. So now I have 50 buyers. Remember, y is the number of buyers, and x is the cost. So I just sub in 50 in for y equals negative x, or negative 1x plus 118. Subtract 118 from both sides, I get negative 68 equals negative 1x. I divide both sides by negative 1, so I get x equals 68. So if I wanted 50 people to buy it, I should sell it at $68. Same thing with 75. Negative 1x plus 118. Subtract my 118 from both sides. That gives me 43. Negative 43. Let me check and make sure that's right. Yeah. Negative 43 equals negative 1x. Divide both sides by negative 1, and I get x equals 43. So in that case, if I want 75 people to buy it, I'm going to sell it for 43. If I want 100 buyers, set it equal to 100 equals negative 1x plus 118. and then subtract my 118, so that gives me negative 18 equals negative 1x, divide by negative 1, and that gives me 18. So if I want 100 buyers, I'm going to sell it for $18. And that's kind of the relationship between the data and our relationship, our equation. And that's linear regression.